All right, let's go and take a look at your homework, if you would. Please, books open to page 294. Page 294. And we are recording these lessons new. So for Scott, and then I guess next year this would be for Jaden and Evan and Rocky, recording these lessons new this year. And so you'll hear some different voices. Actually, you'll still hear Josh and Lana, but they're a year older now. You heard them in pre-algebra. And then Dylan and Adam joining us as well. Number 13, there on page 294 from your homework, we had a 3x over 5 times the square root of x. And the only thing in the entire problem that I care about, class, is the denominator. Specifically what part of the denominator?
Square root of x.
The square root of x. I don't care anything about the 5. I only care about the square root of x. And I have to take the root. But I can't. So what do I do so I can take the root, Dylan?
Multiply by the square root of x.
Multiply, good, not by x, but by the square root of x. And what we do to the bottom? What does the top become when I try to multiply a 3 and an x by a square root of x, class?
3x times the square root of x.
3x times the square root of x. Don't let that be hard. But in the bottom, I've got a 5 square root of x times another square root of x, which initially Josh gives me
5 times the square root of x squared.
But what is the square root of x squared, class? That's just x. So we end up with a 3x square root of x all over 5x, but I'm not done. Adam?
You can cancel out the x's.
But remember, in a fraction, going back to chapter 11, anytime we cancel a variable out of a fraction and it leaves the denominator, I need to set it, class,
Equal to 0.
unequal to 0. So I need to specify then that x cannot be 0. And there would be my answer there on 13. Number 14, we had a 5 over a 2 times the square root of 2. Yes, if you're looking at what is that? The seniors are on senior trip this week and they left me a note, which I've been working around all week. And so it'll be there for them when they get back. What do we need to do here on number 14? Lana?
You try to take the root. Well,
I mean, that would certainly, I would try to take the root if I could. Of course I can't.
So you make it the square root of 4.
By doing what?
Multiplying by the square root of 2.
Good, multiply bottom and top by the square root of 2. So that my numerator, class,
5 times the square root of 2.
and I think we can do this in our heads, right? We know the square root of 2 times the square root of 2 is going to be the square root of 4, but that's just going to be 2. So that becomes a 2. I already had a 2, so my denominator, class, is really a 4. And again, if you can do that in your head, absolutely, why wouldn't you? Looking at the next one, number 15, we have the cube root of a 3 over 4x. And again, you have to take the root of the denominator, but you can't. Can't take the cube root of a 4x. I want to change this denominator specifically to say what now? Adam?
64. Wait, no.
That wouldn't be wrong, but it's not best. 8 would be the best.
I mean, 8x cubed.
8x cubed. And to get an 8x cubed, I'm going to extend this radical sign a little and multiply top and bottom, class, by 2x squared. So that my numerator, which also has to change, even though I don't really care about it, class, 6x squared. So, can I take the cube root of 6x squared?
No.
I can do anything with it. I don't care. It's a numerator. Leave the cube root of the 6x squared. In the denominator, though, class, we get 2x. Plain, old, easy 2x. And there we go. Looking at the last one, we have the cube root of 1/4. And kind of similar, actually a little bit easier, though. Dylan?
Get the denominator 8.
So,
Multiply by 2.
top and bottom by 2. That's what I'm looking for you to say. Top and bottom by. That's important to get
2
the cube root of 2/8. That means the same thing as the cube root of a 4th. It just looks different, of course, but it looks different in a way that I can take the root of the denominator.
Cube root of 2 over 2.
Good, leave the cube root of 2, but now it's all over a plain old 2. Questions on the 13 through 16, they're on page 294. Look back one page, then back to page 293, where you did number 6, 11, and 12 for homework. And we've been working on rationalizing denominators really for a while, though we didn't always call it by that name. We just called it taking the root of the denominator, which is what it is. But then yesterday in our lesson, we began looking at how to rationalize two-term radical denominators. And we said you can't just multiply by a particular radical. You can't just, on number 6, square the binomial. That wouldn't work either. Remember, we said we'd square the first square less than that, multiply and double would get us. What do I have to do, class, if I have a two-term radical denominator.
Multiply by the conjugate.
Multiply by the conjugate. What is the conjugate of the square root of 3 minus the square root of 2, Josh?
The square root of 3 plus the square root of 2.
The square root of 3 plus the square root of 2. And multiply it, class, by top and bottom, both of them. Now in the top, of course, I just have this monomial 7 times this polynomial. What do I need to do there, Dylan?
Distribute
To get?
7 times the square root of 3 plus 7 times the square root of 3.
Good. Don't try to make it a square root of 21 by the square root of 4 plus the square root of 14. The 7 doesn't go in the radical. Here in the bottom, though, always, 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 the purpose of the conjugate class is to create what special case? Sum and difference. And to multiply, we're always going to do what 3 things then?
Square the first, square the last, minus sum of 2.
When we square the first, we're squaring with square root. When we square the square root, class, we get the radicand, which is just 3. And when we square the last, we're squaring a square root, we get the radicand, we just get 2. And we put a minus sign between them. What is 3 minus 2? 1. Anything over 1 is itself. There's your answer right there. How many had this? 4, number 6. Questions? Let's take a look at number 11. We had a 3 minus the square root of 5 over a 2 plus the square root of 5. And Adam, what do we need to do?
You need to multiply.
Class, help him.
You need to get,
Conjugate.
Multiply by the conjugate. Adam, what do we need to do?
multiply by the conjugate.
Multiply by the conjugate. What is the conjugate, Adam?
2 plus the square root of 5.
No, that's what we have. What's the conjugate?
2 minus the square root.
Good. The conjugate is the same thing with a different sign in the middle, so that it gives you the sum and difference. What we do to the bottom? So top and bottom by 2 minus the square root of 5. Let's start with the bottom because it's easier here. 3 steps, class.
Square the first, square the last, minus sum of 2.
Square the first, of course. 4, because I'm not squaring a square root, am I? It's an actual 2, so I get a 4. Square the last. That's just fine, because I'm squaring a square root, get the radicand, put a. This is going to be a little annoying. What do I get in the denominator?
Negative.
Oh, negative. 1. In the numerator, what am I going to have to do, Lana?
You foil.
I'm going to have to foil. What do I get when I multiply the first?
6
The outer.
plus 3 times the square root of 5. Minus.
Watch out for those negative signs. Negative 3 squared root of 5. What about the inner, Lana?
Negative 2 times the square root of 5.
Caught it that time in the last.
Negative 5.
Well, negative times negative.
So positive.
Positive. And you're right. The square root of 5 times the square root of 5 would give me the square root of 25. But I don't want to waste my time writing that down. I'm lazy. I'm just going to put 5. So, Lana, I can combine in the numerator the 6 and the 5.
I mean,
You had 1 because you had the negative, but
Oh.
negative times negative positive means we
11.
should have an 11.
Yeah.
And then the negative 3 squared root of 5, negative 2 squared root of 5, class.
negative 5 square root of 5.
And all of it's over negative 1. Now there's a couple recourses here I want to show you. One recourse is to leave it over the 1 and just slide the negative to the front. That's one option. Nothing wrong with that. It's a little more messy than I like it, but it works. And you say, well, do we have to write the 1? Yes, because a fraction bar is a grouping symbol. And if you take the fraction bar off, it looks like the negative only applies to the 11. But you could make a different grouping symbol. Instead of over 1, you could write it that way. You see that means the same thing. Or you could say 11 divided by negative 1 is negative 11. Negative 5 squared root of 5 divided by negative 1 is positive 5 squared root of 5. And that's the easiest way to write the answer. But it's up to you. Any of those 3 would work. Questions on this, especially maybe the way in which answers are written?
No.
All right. Again, the simplest, easiest way is just slide the negative out front, leave everything else, you don't screw it up. But if you're wanting to be lazier and write it more neatly, the top way is preferred. Let's take a look at the last one from the homework. That was number 12, where we had a 3 minus a 4 times the square root of 2 over a 5 minus a 3 times the square root of 2. And again, I need to multiply, class, by the conjugate of the denominator, because I have a 2-term radical denominator. What is the conjugate that I multiply top and bottom by, Josh?
5 plus 3 plus the square root of 2.
Of course, in the bottom, class, 3 things.
Square the first, square the last, minus sum of 2.
Square the first, class.
25.
25. It's not a square root. Now in the last, I got two different things. When I square the 3,
9.
I get a 9. I square the square root of 2, I get 2. So I've got a 9 and a 2. So really, class, I have an 18. And I put a minus sign between them. So really, my denominator is going to be, class, a 7.
I got 11.
Questions?
I don't know how I got 11.
Okay. All right, let's move to the numerator now. What do I need to do here, Dylan?
Foil.
Foil again first.
15.
Careful with your signs. Outer.
Positive 9 times the square root of 2.
Good. Positive 9 times the square root of 2. Inner.
Negative 20 times the square root of 2.
Excellent. Negative 20 times the square root of 2. And then the last.
Negative 12 times. No.
You're right. Negative 12
Negative
times
4.
the square root of 4, which is 2. So negative 12, sign, number, radical. Negative 12 times 2 would be?
Negative 24.
You don't have to do all this in your head, of course. Let me make sure this is actually on the camera. Yeah, just barely. I mean, you could say negative 12 times the square root of 4, and then change that to negative 12 times 2, and then come back to the negative 24. It's up to you, but we get to that point anyway. We'll combine the 15 and the negative 24, negative 9, and we'll combine the positive 9 square root of 2 with the negative 20 square root of 2.
Negative 11 times the square root of 2.
But going back to chapter 11, we said we couldn't leave an answer like this. Because you can't have a negative first term in a fraction, remember. What do I do so I don't have a negative right here, class?
Factor out the negative.
Factor out the negative, and then
To bring out.
slide it out front. So the best way to write the answer is negative 9 plus 11 square root of 2 all over 7. Maybe you forgot to factor out the negative. How many had the answer otherwise? Or maybe you did factor out the negative and slide it out front. Questions,
I got
comments?
11 somehow on the bottom.
All right,
Yeah.
questions?
Yeah. I don't know how I got 11.
Well, don't worry about how you did it wrong. Focus on how you should have done it correctly. Questions? All right, questions at all? Last call. Well, let's transition into another topic today. We've talked a lot about equations throughout the school year. I want to talk about a new type of equation today. That's a radical equation. Radical equation. Next section, you're going to solving radical equations. Anyone want to hazard a guess as to what a radical equation is? Equation with a radical in it. Pretty good. Little bit more detail than that. A radical equation is an equation with a variable in a radical. An equation with a variable in a radical. You're writing this down in your notes quickly. Radical equation. An equation with a variable in a radical. Meaning your x will be in the radicand. Radical equations. Radical equation with a variable in the radical. Step number 1, and this is your key, so put a star next to it. Step number 1 is to isolate the radical. Step number 1 is to isolate the radical. Get it by itself. Get everything else away. Kind of like we did with absolute value, right? We would isolate the absolute value. Or really the ultimate goal in any equation is to get the x by itself or isolate it. Well, here's the radical that we're going to isolate. And then step number 2 is to square, but put a little asterisk, both sides. Square both sides. Normally, our radical equations are going to involve square roots. If that's the case, we would square to get rid of a square root, because that's the opposite operation, right? We have division, what do? Multiply to get rid of a division. If we see a multiplication, what do? We divide. If we see a subtraction, what do? We add. So if we see a square root, we would square, because that's the opposite, right? But if it's a cube root, we would cube. So it says square both sides. That assumes square root. The asterisk is just, well, you know, if it's a different type of root, you do something else. But normally it's going to be square both sides. Step number 3, solve. Pretty straightforward. But there is a fourth step. Normally, I'm lazy, and I say I don't really want to check my equations. Radical equations are sneaky. It is possible for you to solve a radical equation perfectly and get an answer that doesn't exist. Something called an extraneous root. Have we used that term in this class before? Extraneous root, where you solve an equation, you get an answer, but it ain't really an answer. It's a lie. It's called an extraneous root. So step number 4 is to check, and write this in all caps, check for extraneous roots. Check for extraneous roots. Now, the times you're going to see them the most, and this isn't all inclusive, but this is a good strategy tip of when to be on high alert, especially if you square a negative. Especially if you square a negative. At some point in the process of solving, you're like, oh, I just squared a negative. There's a very good chance you've got an extraneous root coming your way. Check for extraneous roots. Let's start with a couple of easy ones here. Write this down as an example in your notes. The square root of x minus 3 equals 7. The square root of x minus 3 equals 7. By the way, in case you're wondering about the dangling decorations all over, that's also courtesy of the seniors. They quote-unquote decorated my classroom. I left some of the decorations. At this point, they are becoming fewer and further between. Anyway, so the square root of x minus 3 equals 7. First step, class, we need to?
Isolate the radical.
Thank you, Dylan. Class, what's the first step to solving a radical equation?
Isolate the radical.
Isolate the radical. By the way, how do I know this is a radical equation?
Because there's a radical.
It's a radical with a variable, right? So radical equation. Isolate the radical. What do I need to do to isolate this radical, class? No, what do I do to isolate the radical?
Move the negative 3.
Get rid of that negative 3. Move it over, you said, Adam, as a?
10, or the
Positive 3 to get
10.
10. Now, the radical's isolated. We have gotten it by itself. We got rid of whatever was with it. Just like we would have with an absolute value equation, right? Step number 2, class. Square both sides. And it's important to remember as we square both sides that when you square a square root, you get the radicand. So I square the square root of x, and then I square the 100, or I square the 10, 100. And there's my answer, I think. Did I square a negative? No, I never squared a negative. So it's probably not extraneous. Let's just check real quick. Class, what's the square root of 100? Minus 3? It checks. Look at this next one. Write this down now if you would. 9 plus the cube root of x plus 4 is equal to 13.
That's kind of cool.
9 plus the cube root of x plus 4 is equal to 13. Again, I see an equation. How do I know it's an equation?
Radical.
No, how do I know it's an equation?
Because it has an equal.
Equal sign. How do I know it's a radical equation?
Because it has a radical.
Has a radical also with a letter in it, right? And so I see, hey, that's a radical equation. What's my first key step, class?
Isolate the radical.
Isolate the radical. What do I do, class, to isolate this radical?
Move the 9 over.
Subtract the 9 or get rid of the 9, move the 9 over as a negative to get
This
4.
Cube root of x plus 1 equals 4.
the cube root of x plus 4 equals 4. Or we move it over to get 4 on the other side. Now that the radical's isolated, class, normally we will square both sides. But would that do anything here?
No.
Squaring a cube root does nothing. So we're not going to square both sides, class. We're going to cube both sides. And when you cube a cube root, you get the radicand, just like if you square a square root. The cube and the cube root cancel the same way a square and square root would, and I'm just left with the radicand, x plus 4. And on the other side, I'm cubing a 4. 64. Finally, we solve. To get the x by itself, subtract away the 4, or move it as a negative 4 to get x is equal to 60. At any point, did I square a negative?
No.
I didn't even square in this problem, but we should probably check anyway. 60 plus 4?
60.
Cube root of 64.
4.
9 plus 4?
32.
It checks out. I was pretty sure it would, but always good to check and watch out for, what do we call those roots that don't work out?
Extraneous.
Extraneous. And again, extraneous roots aren't roots that you get because you screwed up. Extraneous, that's just wrong answers. Extraneous roots are roots you got by not screwing up, but they still don't check. Write this one down if you would, please. 2 times the square root of x plus 1 minus 1 equals 5. 2 times the square root of x plus 1 minus 1 equals 5. Lana, what do I do first? It's Lana, I'm picking on her.
1 move the 1. No. The negative 1 as a positive 1.
To get
6.
6. Joshua.
You square the square root.
Oh, have I isolated the radical yet?
No, you didn't. So you divide.
Divide away the 2 now. Just as the same way we would isolate an absolute value, we are going to isolate that radical completely. Now that it's isolated,
Then you square both sides.
square both sides. What do I get when I square both sides, Dylan?
X plus 4 equals.
And then what do we do, Adam?
You move the 1 to become a -1, so we have 8, so then x equals 8.
There we go. Let's check real quick. Come back up here. 8 plus 1 class. 9 square root of 9
3
times 2
6
minus 1.
5.
And it checks out. Again, at no point did I square a negative, so I was reasonably certain I would not get an extraneous root here, but it's always good to check. Questions? Turn to page 302 in your textbooks. Page 302 in your textbooks. Now I want you to do numbers 1 through 11, the odd numbered problems. Page 302, numbers 1 through 11, the odd numbered problems. Mm-hmm. Yes, 1 through 11 at the top in the practice section. First one really couldn't be easier, class. What do I have to do?
Square both sides.
Yeah, it's already isolated. Just square both sides to get
X equals 16.
x equals 16. Take the square root of 16 is 4.
Yes.
It checks. But on the next one, watch. I square both sides the same way, right? And when I square the square root of x, I get x. Is when you square a square root, you get the...
That's W.
Radicand.
Oh, it's a w, whatever. Okay. So you square the square root, you get the radicand w, right? But what do you get when you square a negative 11?
One
No.
positive 1.
Positive 121. But when you take the square root of 121, the understood positive square root of 121, is that negative 11? No. This is an extraneous root. And our answer then is no solution. Technically, a square root has both a number has both a positive and a negative square root, but there was an understood positive in front, which implied they want the positive or principal root, which is not negative 11, because we squared a negative, and again, not always the case, but often the case, because we squared a negative, we end up with no solution. Make sense? All right, finish the last 4 of those odds, 5, 7, 9, 11. The other one's not quite as insultingly easy. No, you like a challenge, Lana. You like to show off your great mental acumen.
Yeah.
That's what you like to do. Yeah, I knew I did. I knew that's what I liked.
Are you questioning it, Josh?
Could you get a fraction?
You certainly can get a fraction. Why not?
You can get a fraction.
Sure.
You have to know.
Just follow the steps. Isolate the radical, square both sides. Solve. Dylan's finished. Take about 30 seconds longer to be finishing up, and then we'll go over these together.
Are any of them in a solution?
Possibly so. All right, let's take a look at these. Pencils down, even if you're not finished. Number 5, what do I need to do, class?
Isolate.
Isolate the radical by?
Subtract the 3.
Subtracting away the 3 to get a 2. Once the radical's isolated,
Square both sides.
square both sides. What do I get when I square the square root of 5x?
5x.
What do I get when I square root of 2?
4.
What do I need to do to solve for x?
Divide by 5.
Divide by 5. Ooh, what do I get?
4/5.
Fine, circle it.
I got 2/25. Like, cause
Do the steps. Square both sides.
I thought you would get 25x.
No, when you square a square root, you get the radicand. What's the radicand? 5x. Don't be messing with it, right? Make it easy. All right, now, the checking is not so easy. That 5's really sloppy. The checking's not so easy. Except you're multiplying by 5 anyway, right? So you're multiplying a 5 times a 4/5, right? What's going to happen with the 5 and the 5?
Okay.
So it's really just the square root of 4, which is plus 3 equals 5. It checks out. Look at the next one. Radical's already isolated. Class, what do I do?
Square both sides.
Square both sides. What do I get when I square the square root of x plus 1 line?
X plus 1.
Get the radicand. Good. On the other side, class, I get.
16.
And then to solve, I just
Subtract
1 to get.
x equals 16.
X equals 15. Let's check. 15 plus 1?
16.
Square root of 16?
4.
We're good. Look at the next one. Already isolated. Square both sides. What do we get on the left?
X equals 16.
What do I get on the right?
36.
Positive 36. I subtract away the 2 to get x equals
35.
34. I check. 34 plus 2?
36.
Square root of 36?
Ooh.
6, not negative 6. What do I write for my answer?
No solution.
No solution. What kind of root is the 34?
Extraneous.
Extraneous. It's not a wrong answer necessarily. I didn't mess anything up. It's an extra root that doesn't check. It's an extraneous root. Look at the next one. What do I need to do first, Adam?
You need to isolate the radical.
By?
Moving the 1 to become a negative 1, so it can be equal, the 2 can become a 1, so then it's square root of 9 plus 4.
That's Q.
Cube, 1.
All right. Then what do I need to do, Adam?
Let's see, you square it, and it becomes cube plus 4 equals 1.
And then?
You move things around, so it would be the negative 4, and then it'd be a negative 1, negative 3, so then it'd be negative 3.
All right, let's check. Negative 3 plus 4 class.
1.
Positive 1. Square root of 1?
1.
Plus 1?
2.
It checks out. There we go. Questions on these odd problems. Take a look at number 13. Number 13, copy it down. This one is just a little different. Because notice, on number 13, there is a variable in the radical, right? So it's a radical equation. But there's also a variable not in the radical. We have the square root of x plus 2 equals x plus 2. Notice that the radical is already isolated. So class, I
Square both sides.
square both sides. Notice, not square everything. Square both sides. This entire side collectively gets squared. On the left, I'm just squaring a square root. Class, I get
And x plus 2.
the radicand, x plus 2. But on the right, I am squaring a binomial. What do I get when I square a binomial? Specifically a perfect square trinomial. When I do what? 3 things, class?
Square the first, square the last, multiply and double.
Yeah.
All right. And so when we square the first, square the last, multiply and double,
Yeah.
I end up getting what, class?
X squared
plus
plus
4
4.
x.
All right, square the first, square the last, multiply and double.
Yeah.
And I end up with x squared plus 4x plus 4. Now notice though, what started as a radical equation, class now has an x squared in it. What do we call, careful, an equation with an x squared in it?
No.
An equation with an x squared.
Quadratic.
A quadratic equation. And to solve quadratic equations, which we're going to look at more a little bit later, to solve quadratic equations, class, I have to set them equal to 0. And so I'm going to make this the 0, because remember we like the x squared to be positive, and it has no friends anyway. I'll move the x over as a
Negative.
to get,
3.
and I'll move the 2 over as a to get. Once I've set it equal to 0, then I'm going to
Reverse
factor.
Wheel.
Factor, backwards FOIL. X squared splits into, do this with me. At your seats, you're writing.
X and X.
X and X. Remember, I told you, copy down number 13. This all should be on your paper in your notes for reference for tonight's homework. X and X. The positive sign tells me.
Positive.
Both positives, and then split up the 2. 2 and 1. Or 1 and 2. Actually doesn't matter. Outer inner checks either way. And then I'm going to take each of these factors and set each one individually equal to 0. And if x plus 2 equals 0, class, x must equal negative 2. And if x plus 1 equals 0, class, x must equal
Negative 1.
And it's very possible that one of these is extraneous. Let's check. Let's plug in the negative 2 first. Negative 2 plus 2?
0.
Square root of 0?
0.
Negative 2 plus 2?
Wait, negative 2.
Negative 2 plus 2. We are checking our answer, which means we plug in the value where it says x, like we have.
I know, I was just wondering
Stay
what
focused.
negative 1 does.
We're not checking it yet.
Oh.
We have 2 answers to check. We're checking the negative 2 first. Negative 2 plus 2 is 0. Square root of 0 is 0. Negative 2 plus 2 is 0. That one checks. Let's try the negative 1 now. Now that we're done with the negative 2. Negative 1 plus 2?
1.
Square root of 1?
1.
Negative 1 plus 2?
1.
It also checks.
Oh.
It is not uncommon for one to be extraneous, but this time they both check. Make sure this example is in your notes. Copy number 17 now. The square root of 1 negative 3m minus m equals 3. The square root of 1 negative 3m minus m is equal to 3. This time I need to do my first step.
Isolate the
Isolate the radical. And to isolate the radical, I need to get rid of the negative m by making it a positive m on the other side. It's going to give me the square root of 1 negative 3m is equal to 3 plus m. Or you could say m plus 3. Doesn't really matter. I think we actually might like it better if it said m plus 3, so I'm going to go and write that. But technically it does not matter. Once we've isolated the radical class, square both sides. On the left, when you square, you are squaring a square root. You get the radicand again.
1 plus 2m.
1 minus 3m.
Oh wait, capital plus.
On the right-hand side, I am squaring a binomial. 3 steps.
Square the first, square the last, multiply and double.
Oh, okay. I like the yeah, but I didn't like what I heard there. Let's try it again. Rewind. All right, class, when we square a binomial, 3 steps.
Square the first, square the last, multiply and double.
Yeah.
And so what do we get, class?
M squared
Plus
6.
9.
9x. 6x.
And then 6.
6x plus 9.
M.
I keep thinking
6M.
It's a Friday. They're tired.
It's supposed to be field day.
It's supposed to be field day today, and it got rained out, so we're having field day later. So anyway, it is what it is. All right, so we've got a quadratic again. Once again, set it equal to 0, which means the negative 3m comes over as a positive 3m to get positive 9m, and the 1 moves over as a negative 1 to get a positive 8. Once I've set the quadratic equal to 0, class, I need to factor, backwards FOIL.
Leo. M plus 8,
M plus 8, M plus 1, he says. Does that sound good to the rest of you?
Yes.
Everything checks out. Set both of them equal to 0 individually. I get 2 answers for M.
Negative 8 and negative 1.
Let's check. I'm going to start with the negative 8. Check it all the way through. If I plug in a negative 8 times negative 3, 24 plus the 1,
25.
stay with me, square root of 25, 5. Minus negative 8 becomes
Negative 3.
plus 8. 5 plus 8, 13. Does that equal 3?
No.
This is extraneous. Now let's check the negative 1. Negative 3 times negative 1. 3 plus 1.
4.
Square root of 4.
2.
Minus negative 1 really means
Plus
plus 1. Does that equal 3?
Yes.
This one checks, that one doesn't. Questions on that? For homework this evening, need you to do page 302. Page 302. Practice 2 through 14 even. Page 302. Practice 2 through 14 even. And review 1 through 4 and 20. Page 302. Practice 2 through 14 even. And review 1 through 4 and 20. All right, have a wonderful rest of your day. Have a great weekend, and we'll see you back on Tuesday.